Hello students, this will be the final lecture in our medium series. The topic today is architecture, and this is also the final lecture of the course. Architecture is a very important medium simply for the fact that we occupy a building every single day. So there's an architect that designed all the different spaces that we move through, and they have an effect on us psychologically, emotionally, whether we're aware of it or not. And oftentimes we can live in buildings that are somewhat bland or understimulating, but then when you go into a building that really is grandiose and well constructed, you can get a sense of how much that does affect you. As you'll see through various important buildings, monumental structures that have been created throughout history that we'll explore in this lecture. So thank you for tuning in this semester, and this will be our final lecture, so please enjoy.
Architecture is three-dimensional design that surrounds and influences us, connects us to our history, suggests feelings of permanence. They are produced by an architect, an interior designer, and a landscape architect. These are pictures of the Sagrada Familia, designed by Antonio Gaudí. Architectural engineers create a balance between tension and compression. That's push equals pull. Each building's material resists compression or tension differently. If balanced correctly, a building can stand for thousands of years. So Antonio Gaudí, the Catalan architect from Barcelona, began construction on this church in 1882. He spent the last 15 years of his life working on it, and it's still being constructed to this day with anticipation to be completed in the upcoming decades. This church is considered Gaudí's magnum opus. The basilica is a UNESCO World Heritage Site and one of the most visited monuments in Spain. The interior is designed to resemble a forest, with columns branching out like tree canopies. It combines Gothic and Art Nouveau forms with a profound symbolic meaning related to Christian theology. Inspired by nature, Gaudí incorporated organic shapes, curves, and intricate details that mimic natural structures. He also did this innovative technique of hanging his models upside down to use gravity to design the spirals and towers. The central tower of Jesus Christ will reach a height of 172.5 meters. That's 566 feet, making it the tallest church building in the world upon completion. This is one of the great masterpieces of architecture, and if you're ever able to get to Barcelona, you should definitely check it out. The stained glass windows, the sculptural facades, everything about it is carefully planned and detailed. It's important for form and function and design to interact and form a balance with architecture. You have to walk through these spaces and live in them or use them for some sort of purpose. So the function is very important. This mosque, designed by Sinan, the Turkish architect from the 1500s, elaborately constructed this out of domes and half domes, and it was perfectly balanced, enduring for more than 500 years. The way that he constructed it with the half domes allowed for lots of windows and light to come in. The worshiper would feel compelled to look up into the heavens the way that the ceiling was designed. Architecture often starts as a blueprint, a drawing in the old days that would show the entire structure. Sometimes architecture can seem glamorous, but in reality, it's a lot of planning and engineering and work. Architecture can start out as very simple sketches or designs, even gestural sketches. Fumihiko Maki did this drawing for the World Trade Center. Started out as a very simple curved line that then could integrate the World Trade Center with the surrounding architecture. Also, Frank Gehry is known to make scribbly gestural drawings and to sculpt household objects as inspirations for the designs of his buildings. So architecture can start out as a very simple and free and loose idea. This is the Temple 1 in the Great Plaza of Maya. This is Guatemala, Tikal, Guatemala, constructed in 300 to 900 CE. Most ancient cultures derive their building materials from the earth, stone, wood, and clay. Stone, wood, and clay must be modified for their use in construction. These raw materials can result in architecture that transcends time. This temple follows the direct process of just piling one stone or brick on top of another to create these massive load-bearing works. And these works have been built throughout history. You see this not only in ancient South and Central America, but also Egypt, Rome, Southeast Asia. This is a diagram of how it works. So one platform with bricks stacked and smaller platform, load-bearing structures that just stack up until they reach a height. Here's Chichen Itza, which is in Mexico, one of the biggest pyramids of that area. And it seems every other day there's an article coming out about more discoveries of ancient structures, architecture that has been buried in the jungle and covered over, sort of rewriting the book on ancient civilizations as we go day by day. If you look closely, you can see that there is a connection between ancient structures and contemporary structures. See how they're built, connected, clustered together to form communities in a very similar way. All right, we're going to go through different building methods throughout time. We've already covered the load-bearing, stacking bricks on top of each other. Now let's go to the post and lintel construction. This is basically when you have two posts and a lintel, which to create an interior space, an architect must create a span or a distance between two supports. In basic post and lintel construction, the lintel rests on top of two posts. So the post and lintel construction is used to monumental success in the Great Court at the Temple of Amun-Ra, hypostyle hall, a room created by using a series of columns to support a flat ceiling. This was used by Egyptian priests for rituals to worship the god Amun-Ra, and it's one of the largest religious structures in the world. So the high priest would go inside of this hypostyle hall and worship, do their rituals, but ordinary people would not be allowed into this center court. They would have to stay outside. The ancient Greeks also used the post and lintel construction, and the architects must have been aware of the majestic structures in the Nile Valley, because the ancient Greeks adapted the systems invented by the Egyptians and then standardized them into three distinct types of columns. This is a temple of Athena built in Greece 415 CE, BCE, using the post and lintel. Here are the three different kinds of columns that they used. The standardized column is an essential point of compression to support the weight of a building. You have three parts to it: a capital, that's the top part; a shaft, that's the long skinny part; and then a base, which is the bottom part. Here's a diagram here. And the three different ones, the Doric, the Ionic, and the Corinthian. The Doric just has the normal sprouted end. The Ionic has the circular scroll, and the Corinthian has a floral decoration on it. So if you see one of those three, and sometimes they're on American buildings as part of classical revival architectural constructions. So also in early architecture, lintels could not span large spaces. Stone would snap under the heavy pressure. That's why ancient temple in Karnak of Amun-Ra has so many posts, because you couldn't create a long span. You had to put tons and tons of arches to create that interior space. So instead, they created the arch, the corbelled arch. That's where bricks are stacked and slowly come inwards progressively. And then there is the rounded arch, which is more like the Romans used, that pushes the weight of the load outwards. So the corbelled arch is mainly used by the Babylonians and the Mycenaeans, and the rounded arch is perfected by the Romans. This is the treasury of Atreus. It's a very old building, 1250 BCE in Mycenae, Greece. Early Greek construction that uses this corbelled arch, as you can see here, progressively cantilevering the stones above the lintel allows for more light to enter the chamber. Here's a diagram of the rounded arch, where the weight is channeled to the posts for spanning larger areas. The Romans perfected this rounded arch. It's a more efficient way of distributing stress over the whole structure. It efficiently helped the Romans span wider spaces than previous architects had managed. This is the Point Augod. It's an ancient Roman structure in southern France. It's an aqueduct and a bridge. No mortar, stones fit perfectly together. No mortar, can you believe that? Benefited the local community, and it projected Roman imperial power. So the Romans brought water down this arch. It all goes downhill and brings water into the city. It progressively gets smaller or shorter and shorter, so that gravity will bring the water. Amazing ancient structure and use of the arch. The arch is also used in the Colosseum. The Colosseum is essentially made of tons and tons of arches stacked on top of each other, around and around and around. One of the great buildings of the ancient world. Was a stadium for Roman gladiator games and spectacle. Next, we have the barreled vault. This is the most common type of vault. The barreled vault consists of a long semicircular arch. So it's basically tons and tons of arches stacked on top of each other. Here's a vault from a church in France. A vault is an arch that has been extended like a long hallway to create an open space overhead. So this is a perfect example of a barreled vault. Can span larger areas of interior space and was very important during the European Middle Ages. Here's a diagram of a Gothic architecture barrel vault. You also have flying buttresses, which are support to transfer the weight of the arch outwards. So we have buttress is this area that spans an open space supporting the barreled vault. It's how weight is transferred. Abbot Suji, he believed worshipers should be bathed in divine light. So he redesigned churches to have these enormous windows, all this light coming in, should feel uplifted towards heaven. So they had to use the flying buttresses to allow that type of support, because before that you would have these very austere churches. So you have these pointed arches, ribbed vaults. Next we have the Hagia Sophia. This is structure, and the innovation in the Hagia Sophia is the dome. Structurally, a dome is an arch rotated 360 degrees on a vertical axis. It's a very strong structure and can span large areas because the weight is dispersed outwards toward the walls. Here's a diagram of it. And this is the interior of the Hagia Sophia in Istanbul. It's a Byzantine structure, impressive, enormous dome roof. It's the largest interior space of any cathedral for nearly 1,000 years, until it was surpassed. There's illuminated clerestory windows, and pendentives transfer the load to the circular dome on 4 massive pillars. This is another one of the great architectural wonders of the world, and it was a Christian church during Byzantine times, and then it was transferred into a mosque. So it's been many things throughout its history. Amazing church in Istanbul. The next innovation is the post and beam architecture. Post and beam construction technique had been used to build some of the world's finest wooden architecture. This is used in medieval Japanese architecture. In the 7th century, the Horyuji Buddhist temple was constructed in Nara, Japan. Yomoni, who was the emperor, he built this temple for divine spiritual favor because he was sick, but actually died before it was completed. Although the empress and the crown prince finished the construction on this temple, fulfilling his dying wish. It is still standing to this day, one of the oldest wood structures in the world, a testament to how well these structures can last if built with great craftsmanship. Let's now talk about the building materials of the modern world. The stick-style house, this is a stick-style house in Ontario, Canada, built in 1832. This is what they call balloon framing. It was originally a derogatory term because people would say that it was very poorly constructed. It was invented in 1832, commonly used in the US today. It's lightweight wooden frames that support the structure, and using power saws was the big innovation with this. Once you could use power saws and quickly cut lightweight wood, you could create these complex frames. The stick style has a decorative design and asymmetry with steep roofs. In the 1850s, we have this innovation called cast iron. Skeletal cast iron structures support glass and walls and roof. This is inspired by architects like Eiffel. This was a great example of the skeletal cast iron glass that was used in Joseph Paxton's Crystal Palace. It was designed for the Great Exhibition of 1851 in London and was eventually destroyed by a fire in 1936. Cast iron had been around since ancient times, but it was never used in mass quantities until the 1850s or so because of industrial production methods. Louis Sullivan made the Wainwright Building. This is considered one of the first examples of modernism in architecture, and Sullivan is considered the father of modernism. He pioneered the use of steel, and basically he was the original creator of the skyscraper. He used the term form follows function and created a versatile interior space, while the exterior of the building reflects the elements of the column, as you can see, the column of the ancient Greek. Steel is a strong material that is made from iron and small quantities of carbon. It's stronger than pure iron and has way greater potential. It can be molded into myriad forms to create very strong, sturdy designs, and it can also be paired with concrete for even stronger designs. Ludwig Mies van der Rohe proclaimed less is more. Because that the steel frames could carry the load of the building, many modernist architects realized there was no need to use a facing material such as stone brick, and you could sheathe the entire building in glass or maybe sheet metal. So this leads to a collapse of facades or decorative elements that you would see in earlier buildings. There's another example, Marcel Brewer from Duluth, Minnesota, and Paul Randolph, the Bass resident in Fort Worth. Le Corbusier, the international style, he proclaimed buildings as a machine for living, should use inexpensive and industrial materials and use strong geometry that is unadorned with decorative elements. These are all Frank Lloyd Wright buildings. He's considered the prime example of modernism. This is one of his masterpieces in Wisconsin, Taliesin. He also designed the Lakeland campus in Florida, the Guggenheim Museum in New York, designed to be a spiraled structure. Frank Lloyd Wright believed in organic relationships between site and building, location, materials, and design. So he believed you should use the materials of the local area and that your architecture should blend into the surrounding environment. Frank Lloyd Wright is a celebrated American architect, and you can see his buildings throughout the whole country, although they're mostly in the Midwest. And many of his students also created buildings that you can find all over and share his similar style. He had a very domineering personality and an interesting life. The Church of the Holy Cross Temple in Sedona is actually done by a disciple of his. The most impressive steel structure in the world is the Burj Khalifa. It is the tallest man-made structure when it opened in 2010 and is still the tallest. The design was derived from spiraling minarets of Islamic architecture, calling the faithful to prayer and worship. The structure framing is tubular steel, making the support even lighter so it can sway. Adrian Smith was the architect and Bill Baker was the engineer. This is in Dubai. So concrete is another big innovation in building materials. Concrete is a mixture of cement and ground stone. It is reinforced through the use of fibrous material or steel rods called rebars to prevent cracking. Widespread use in the 19th century poured into a form. The Sydney Opera House is a testament to the expressive character of reinforced concrete. The roof lines resemble billowing sails. The sails were created over precast ribs and then set into place. Very unique building. We're in a period of architecture called the postmodern now. Frank Gehry is one of the innovators of postmodern architecture. This is his Walt Disney Concert Hall. Postmodern architecture utilizes any materials. Sometimes they're unconventional materials. The shapes and forms have tons of variety. This is a cat house. This is an example of Amsterdam architecture, but just stacked all on top of each other into a giant puzzle piece. Markel, Rotterdam, Netherlands. This is a wild arched building, has projections on the wall. We have the Dancing Building in Prague and the Lumas Arels Art Center. These are both designed by Frank Gehry, and the very famous Guggenheim Bilbao Museum designed by Frank Gehry. Frank Gehry often will design his buildings with garbage or cardboard and uses them from a sculptural perspective first. And then he has his engineers take his sculptures into their engineering programs where they will then make them structural and sound. So he's been called very impractical and often goes way over budgets with his designs, but they are beloved and huge tourist destinations upon completion, and they use often unconventional building materials. Architect Zaha Hadid was the first female architect to win the Pritzker Prize, which is the highest prize an architect can win around the world. Zaha Hadid created this gallery, Contemporary Art Center in Cincinnati, Ohio. It's a three-dimensional jigsaw puzzle, offers organizational flexibility. Visitors are drawn by the dynamic public space. Seen from the street, the building appears weightless and sculptural. Zaha Hadid pushed the boundaries of geometry and form. Her work is often featured futuristic and organic designs. She's been a pioneer in digital design and parametric modeling, a technique to create complex and fluid architectural structures, which has become a landmark of her style. First woman to win the Pritzker Prize. In our current situation, inexpensive alternative materials can be used to create. California homes can be extremely costly, so based on a prefab module such as sustainable wood, double pane windows, roof solar cells, and recyclable materials were used to create the Michelle Kaufman House. Because of climate change, soaring housing costs, and inefficiency in older designs, there's a push to make these cheaper and renewable buildings that are made out of recycled materials. That's where we're at in our current state. Try to make a building that can be sustainable for the future. That will be our final lecture. Thank you for joining in all semester. I hope you learned something, and good luck on your final. Thank you.